So for today's lesson, we're going to be writing systems from word problems. So the first step would be to identify the x and y variables. Then we want to make sure we use the correct symbol, the inequality or an equal sign. We're going to then graph the system, and then we're going to interpret the solution. Go ahead and copy that first problem. So the admission fee for a small fair is $1.50 for children, $4 for adults on a certain day. 2,200 people enter the fair and 5,050 is collected. So we're talking about tickets and the prices for the tickets. So what kind of tickets are we selling? Well, we're selling children tickets, and more specifically, we're looking at the number of children tickets. We don't know what it is, so we're going to call it X. Then we're also having the number of adult tickets. Also don't know the quantity, so we're going to call that Y. On a certain day, 2,200 people enter the fair, so that's a total. We've got a total of 2,200 people, and we also have a total for the money collected, which is 5,000. So those two totals basically tell us the types of equations we're going to have. The first one is going to have to do with the number of people. The next one will have to do with the dollar amount. Now there is some information about the children's tickets that we have. Each child ticket is going to be $1.50, and each adult ticket is $4. So let's go ahead and put our total first, so two totals, because the 5,050 is talking about the total amount of money. Then the money is coming from the tickets, so we're going to have $1.50 per child ticket plus $4 per adult ticket is equal to $5,050. Now for the number of people, we know that each ticket represents a person. So X represents the number of children that attended, and each Y will represent the number of adults that attended. So we've got X plus Y equals 2,200 people, and then $1.50 per child ticket plus $4 per adult ticket gives us 5,050. So once we're done, we're going to go to our Desmos, and we're going to enter the two equations. If we enter the equations, we want to look for it. You can push these little double arrows. And let's zoom out because those totals were pretty big. There it is. All right, so once you see it, if you click with your mouse on the intersection, their intersection is their solution. So we have 1,500 and 700. So our point is going to be at 1,500 and 700. Your X, remember what our X represented, is the number of children tickets, and our Y represented the number of adult tickets. So by the way we interpret it is we say 1,500 child tickets were sold and 700 adult tickets were sold. All right, we got another example. Go ahead and write it down. We've got 3 apples, 2 pears that are cost 60 cents, 4 apples and 1 pear cost 55 cents. How much does each apple cost? So we're talking about two situations and we have two totals. So we have the total of 60 cents and we have a total of 55 cents. And we bought apples and we bought pears. We don't know how much apples cost, so we're going to call that X. So the cost of apples will be X. We don't know how much each pear costs, so we're going to call that Y. So Y will represent the cost of each pear. All we do know is that we bought 3 apples and 2 pears, and my total was 60 cents. I'm sorry. We're going to have 3 times the cost of each apple and 2 times the cost of each pear will give us a total of 60 cents. Then for our second situation, we have 4 apples, so we're going to do 4 times the cost of each apple plus we've got 1 pear, so 1 times the cost of each pear will give us a total of 55 cents. So in this situation, our equation just naturally comes out. So once we have our system, now we're going to graph it. And since it has one already, we're going to push those arrows, click on this little circle or the wheel, delete all, and then we start typing in the next problem, the problem that we just got. All right, so if you notice, it's down here is my intersection. So I'm going to click on the intersection to get my point. It's 0.1 and 0.15. So let's write that down. Our solution at 0.1, 0.15, and then we go back. Our x represents the cost of apples and our y represents the cost of pears. So to interpret, we say the cost of each pear, the cost of each apple is 10 cents and the cost of each pear is 15 cents. If you guys go to Google Classroom, there is some extra practice on the quizzes that you can use for more practice on systems of equations. Now let's go into systems of inequalities. Write the problem down. Okay, we have at most, you can work at most 20 hours per week. You need to earn at least $92 to cover your weekly expenses. So your dog walking job pays $7.50 per hour, and your job as a car wash attendant pays $6 per hour. Write a system of linear inequalities to model the situation. All right, so we know we have two totals. The first total is at most 20 hours. So whatever my inequality is, or the expression to represent the other one, cancel that last part. So at most means that it is either 20 or less. 20 will be the maximum, which means that this side has to be less than or equal to. So the symbol that represents this side being less than or equal to will be the symbol. So less than or equal to because it says at most. Then we have another total. It says at least $92. So in this case, we have at least $92, which means whatever's on this side has to be that amount or more. So 92 is the minimum. So this is going to have to be greater than or equal to. And that's our symbol that represents that. Okay, so now we have your dog walking job. So there's one of our variables, job walking dog. Dog pays $7.50 per hour. We don't know how many hours he works, so we're going to represent it with X for the job. So the dog walking job. We'll put hours at the dog walking job is $7.50 per hour, and we're going to use X. And then the next job that we have is as a car wash attendant. So we're going to say how many hours worked as a car wash attendant. We know that's $6, and we're going to use Y to represent the number of hours that he worked as an attendant. So in this case, when we have the 20, that's talking specifically about the hours. The $92 is the pay. So this is where we're going to put the numbers that have a dollar value to them. So for the 20 hours, we don't know how many hours he worked at the dog walking job. So we're using X to represent it. We don't know how many hours he worked as a car wash attendant, so we're just using Y to represent that number of hours. So that's going to be my inequality, X plus Y less than or equal to 20. Then we go on to the pay. That is where we attach that pay to each one of the hours. So we have $7.50 per hour he worked at the dog walking job, plus $6 for every hour he worked as a car wash attendant. So that's our second inequality, 750x plus 6y greater than or equal to 92. Now we're going to go to decimals so we can graph it. So it's already graphed. If you're having an issue on how to get this inequality, down here there is a little keyboard-like thing, and all our inequalities are down here. All right, so I'm going to make this smaller. I'm going to look at the double shaded region, and this is where we need to look at reasonableness. I'm going to zoom it out a little bit. Because we're talking about hours, we want to ignore everything that has a negative variable. So we're going to ignore everything in this quadrant, everything in this quadrant, everything in this quadrant. So we're just going to concentrate on this double shaded region here. I'm going to zoom this part out. Now, any solution or any point that falls within this double shaded region will be a solution. So in this case, I'm going to choose this point right here where x is 10 and 5 is y. So I'm going to put 10 and 5 where my x is 10 and my 5 is y. Your x represents the hours dog walking, and the y represents hours as a car wash attendant. So to interpret this, we're going to say that, because it's talking about us, we're going to say I can walk a dog 10 hours and work 5 hours as a car wash attendant in order for me to work less than or equal to 20 hours, or at most 20 hours, and at least get $92. Because it's an inequality, there are different other solutions that we can come up with. For example, we can say we can work 5. If I'm looking at this point right here, I can work 5 hours dog walking and 10 hours at the car wash, and that would still satisfy both conditions. Go ahead and pause the video so you can write down this next problem. So on this next problem, we're talking about plants, buying plants and soil for a garden. We've got soil cost $4 per bag, plants cost $10 each, and Marcia wants to buy at least 5 plants and spend no more than $100. Write a system of linear inequalities to model the situation. So we've got two totals. We've got at least 5 plants, which means anything on this side has to be, because it's at least, that's the minimum. So this side needs to be greater or equal. My inequality would be this one. Then my next total is no more than $100. So no more than 100, which means this side over here, no more than means that's the maximum. So this side needs to be less or equal. Less than or equal. All right, so it says we have soil, which is $4 per bag. So X is going to represent the number of bags. And then we have plants cost $10 each. So the plants, I don't know how many we have, so we're going to use Y to represent each plant. And the cost is $10. For it to be no more than $100, we know we're going to use the dollar amount for that equation. So we're going to say if we're buying $4 for each soil plus $10 for each plant, it should equal or be less than $100. Now for the plants, we need to buy at least 5 plants. We don't know the value of the plants, so we're going to be using Y has to be greater than or equal to 5 plants. So those are our two inequalities. We've got Y greater than or equal to 5, and 4x plus 10y is less than or equal to 100. Now you might be wondering, why are we not using the x? Well, this statement didn't talk anything about the soil, so we don't need to put the x. All it talked about was specifically plants. We just need at least 5 plants. Go to Desmos to graph it. And again, we want to be careful not to use any negatives. So we're just looking at this section here. And it could be any combination. So let's choose a point. And I'm going to choose 5, 6. So your x is 5, your y is 6. Part of my solution set because it's in the double shaded region. So we're going to go 5, 6. Your x represents the soil. The y represents the number of plants. So to interpret this, we want to say that Marcia can buy 5 bags of soil and 6 plants. And buying 5 bags of soil and 6 plants will satisfy both conditions. It is at least 5 plants, and they won't spend more than $100. There are problems on